Good morning, everyone. I'm Sotadeology. In today's video, we're going to dissect Sotadeology Lecture 4, the interlocking of dimensions. So now we're going to use this particular formula of everything to arrive at time energy wave model. Then we're going to explore the equilateral triangle, and it is being flipped at the central point into the uh, black hole towards the singularity of the black hole. So this is what we're going to use, and as you can see, we have the mass worth of electron right here, but in this case it happens to be positron. It's actually outside the time energy wave model. So we're going to explore how there is this uh, trajectory beyond the time energy wave model that actually leads to interlocking of dimension. So what I'm actually saying about interlocking of dimensions is that the full reality of two dimension is dependent on three dimension, while the full reality of one dimension is dependent on two dimensions. So we have the hierarchical transitioning to higher dimensions as such. So now let me give us a typical example of of interlocked dimensions. A typical example of interlocked dimension will be a situation where we have deuterium in nuclear fusion. We have deuterium and tritium. For them to actually make a bigger element, which is helium, they would need to actually merge. So now at the point of that merging, there is going to be this huge repulsive force. So basically, I use this uh, as uh, as analog of having that merging towards the edge. And so once that helium is being formed, then we're able to actually go beyond the constraint of hydrogen, and then hydrogen will have its own full reality at the birth of the helium. So that is what I'll give you as a typical example. But as we dive deep into today's topic, you get to know that the structural dimensions that are being interlocked uh, with one another, that is what we have as the structure of the universe. So now let's dive into it. So I want us to start with what we have here. So this is a Schrodinger wave equation. So we need to know the quantum mechanical system, and then having known that, we can relate that to the classical mechanical system, because basically we know that what formula of everything does is to unify quantum mechanics to classical mechanics. But in this particular video, we're going to go deep into the interlocking of dimensions. So now, first of all, when you look at this Schrodinger wave equation, we have this to be total energy, and that total energy must be equal to the kinetic energy and the potential energy. Now, when you look at this kinetic energy, we have minus here. It means that the trajectory of this kinetic energy is inversely related to the potential energy. By having this positive sign, it means that this potential energy is suspended to this kinetic energy. So basically, I want us to see this. What I just explained now using the Schrodinger wave equation is synonymous to what we have right here. So now the trajectory of the kinetic is this, which is here we have the constancy of light speed, and here we have constancy of gravity. And you can see that at the extreme end we have convergence of energy density, and here we have convergence of energy density as well. So I call this a classical arbitrary suspension, as you can see here, why this is called quantum arbitrary suspension. So now we can see that immediately after the limit of constraint, we usually have convergence. And now, right inside this system, we have the real classical mass, which is this particular value. So basically, when we substitute the electron's mass worth, which is this, inside the formula of everything, then we're going to get the counterpart, which is going to be this classical mass worth. And this is its position. And so right now, the real quantum mass worth is outside the system. And in this case, it's a positron, because the system will be flipped. And then by having that flipped system, it will inject this positron into system. Then we can have momentum into the black hole. Now, let's see how we, in this Schrodinger equation, we can see that we have imaginary number right here, which is square root of -1. Now, when you have square root of something, it's more or less like it's more or less like a system that flips trajectory. So now this imaginary number is telling us that the trajectory of electron is negative, just as what we have here. But by having it to be in square root, then it will be flipped. Many people don't know this. So what this Schrodinger wave is telling us is that the total energy of the kinetic energy and potential energy is far more beyond the constraint of the constant light speed. You understand? That is what it's telling us. So now, people don't know that this potential energy will be suspended at the extreme end of the constant momentum of electromagnetic field, which is kinetic, what we have right here. So now, basically, we're going to go so deeply into this for us to understand this whole thing. So now, this whole system, the total, I call this I imaginary number, and I call it to be flipped induction of complex system beyond the wave boundary. Take note of that. So now the H bar that we have here, that is this particular value, which is having Planck constant divided by 2 pi. So we have this particular value. So now this term that we have here, that is partial derivative of psi to partial derivative of time. So the essence of having the partial derivative is for the fact that the psi is a function of position and time. You understand? Is a function of x and t. That is why. So now this is actually telling us that this particular term is telling us how much the wave function psi changes with time. And then we have this h bar to be the smallest energy chunk that can exist in quantum system. It sets the scale at which quantum effect becomes significant. So now, by having this term right there, it has actually limited it to the quantum level. You understand? And that is where the problem is. For us to get the full picture of the universe, solution must come from the classical realm. So we're going to have the necessary energy gap that can, nullify the interference that could cause drifting of particle, for us to really have the actual position of the particle in the system. So now, the kinetic energy, this term is the kinetic energy, and this particular term is the potential energy. So basically, we're going to use a boundary that is being set by uncertainty principle. And that boundary, we have this term which says that the changes of position multiplied by changes of momentum must be greater than or equal to h bar divided by 2. So we have this to be the value of that. You understand? So right now, we have we have h bar to be this value, divided by 2, then we have this. Now this is the quantum boundary. So if we go down to this place, we can see the boundary right here. This is the boundary, the quantum boundary. So I'm actually using the solution of formula of everything. I'm relating the solution of formula of everything to Schrodinger wave equation, and then the boundary. So now we have this to be the boundary. Now, if you look at what we have here, which is 5.7 times 10 raised, this is where the suspension, this is the wave amplitude. This particular value is referring to this wave. So this is where the suspension stops. So now the value that we have as our own suspension right here, you can see it is 5.7 times 10 raised power minus 31 greater than, and it is greater than the quantum boundary that we should have. And as a result of that, it means that we can have virtual particle. So the virtue of uncertainty is being eliminated. And basically we can see that this is our own boundary limit in this time energy wave model, this particular value. And that is what we have here, which is greater than this particular value. Now, then it means that the positron's value, which is this, is greater than this. Definitely the position of our electron will be outside this boundary. So that is why in the Schrodinger wave equation, we have this I, imaginary number, which is, it means that this Schrodinger wave will go beyond the real realm into the complex realm. And so the totality, the total energy of the system is more than the 2D constraint. So it will transit into 3D realm. So definitely the totality of kinetic and the potential energy will be beyond the constraint of the 2D time energy wave model. That is what this is telling us. Now, for us to have this to be like that, definitely we need to consider some 4 terms in deriving this Schrodinger wave equation. First of all, the Broglie hypothesis must be satisfied. The Broglie hypothesis says that mass, particle, matter must be interpreted as something that has wave property. And by having such wave property, then for us to have a nucleus that is being suspended to electron, then there must be a point where the wave trajectory of electron must intersect that of the nucleus to have standing wave. And by having standing wave, that is only when we can have order out of chaos. And that is what could make electron to be suspended to nucleus. So basically, to now get that, to see how that is satisfied by deriving this Schrodinger wave equation, we will have to move to this next paper. So now, the Broglie hypothesis must be satisfied. Then another thing that must be satisfied is that energy conservation law must be satisfied. That simply means that we should have a kind of constancy that is being restricted somehow. So when we go down to this time energy wave model, we can see that we have constancy of light traveling inversely to constancy of gravity, and that is the virtue of energy conservation. Now, for me to explain how energy is being conserved in this particular system, you see that as this trajectory is going towards the low energy state at quantum level, we have accumulation of mass formation towards the low classical energy level. So it means that the decaying virtue of electromagnetic force supports the mass formation at classical level. So you can see that that sign of energy conservation right there. So now let's get to this particular one. So now there is a particular question that came up that actually led to the issue of black body radiation problem. And that problem was solved by Max Planck. So now the question is, how much light different materials emitted as a function of temperature? Now, that when they now set up a particular system, they have a box, they have a tiny hole right inside the box, and they focus laser beam inside the space. And as that laser beam goes into the box, it will, bounce off the wall, and then it will be absorbed. So by hitting the wall, the electrons of the wall material will actually generate another wave that will travel inversely to that laser beam's wave. And at the point where we now have interference that becomes static and undulating, we now have the standing wave. And that is the phenomenon of the nucleus being suspended to electron. So that is that. But there is a particular problem. They realize that at a short wavelength, something above 500 degrees Celsius, they realize that the whole system lead to infinity. So now, how can that problem be solved? But at low temperature, which is maybe from 0 to 500 degrees Celsius, we have infrared spectra. But at higher temperature, we have identical distribution of light glow. That is the basic problem. And they realized that the hotter the object, the more energy was emitted at every wavelength, and the peak of the distribution gets shifted to the left. So this peak gets shifted to the left. So that is where the problem is. So now, at temperature of 1500 degrees Celsius, we realize that infinite radiation at short wavelength becomes what is known as ultraviolet catastrophe. Now, how can this problem be solved? Now, Max Planck did something so outstanding. He had to develop a particular constant. And now what he did was he adjusted that constant to fit the experimental result. And as a result of that, that problem gets solved. So the constant is what is known as the smallest quantum, the smallest chunk of energy at quantum level. And that is the beginning of quantum physics. So now what Max Planck did saw that problem, but he was somehow skeptical about the whole solution, because what he did was he invented a particular constant that he adjusted to fit the experimental result to solve the problem. But basically, it's more or less like there is a particular hand guiding his hand. So now we have the Niels Bohr effort here. Now what Bohr did was, he was of the opinion that why is it that the nucleus is suspended, or why is it that electron is suspended to nucleus? So in his attempt to solve that particular problem, he realized that there is an angular momentum, and by solving the problem, he came up with this particular formula, so which is mass times velocity times radius. And so we have O number multiplied by Planck constant divided by 2 pi. And so we have NH bar. So now the energy level is being interpreted as integer in this case. So now we now have the solution of Louis de Broglie or Louis de Broglie right here. We have his own solution because in his own case he said that every mass matter particle must be interpreted as something that has wave property. And so we have a lambda to be the wavelength equal to h divided by m multiplied by velocity. And that is going to serve as our wave function. So now, for us to have wave function, there must be a point where the circumference of electrons wave intersect with the circumference of the nucleus. And so we have this particular formula, which is 2 pi r equal to n lambda, which is a wavelength right here. So by the time we substitute that in Bohr's equation, then we're going to have it to be 2 pi r equal to nh divided by mv. So now we have that. So the solution is basically what this is telling us is that there should be a static and undulating, wave, which is similar to what we have in the application of formula of everything, to have static and undulating field at the present phase. So now, if we're to look at this, we have 2D right here. And I've told you that we have relativity. And if this is our one dimension, the relativity we have a kind of trajectory that goes from the center away towards this, from the center to the singularity. Here we have energy density, and here we have mass density. And so the relationship goes round the 2D. So where we have this merge convergence, you can see that we have two similar energy type crossing, and here we have the same thing. So that is for the 2D. Now, when we now look at this time energy wave model, at this central line where we have the solution of formula of everything, the trajectory must actually travel beyond this symmetric nature of the universe to connect to the quantum real mass world, which is positron. And the moment that is being injected into the system, that is when we can have trajectory into the black hole. So now, if you come down right here, you will see how that is being achieved when we apply formula of everything. So now, this line, this central line, as you have it, if we zoom on this line, we're going to have this. We're going to have this, and this is going to serve as the Star of David. The Star of David is pointing to the reality that we have at the present phase of time peregrination. And so this is more or less like event horizon at the black hole. So we have the interlocking of future and the past. I told you that the present phase is the static combination of the past and the future, and that is what we have here. So here we have compacted electromagnetic field, and here we have compacted gravitational field. So now the interconnectivity of dimension can be in form of having missing electron that we attract 3D to connect to it, or having a positron that gets injected into the system. So that is that for this particular video. I will put link to my research publication in the description below. You can click on that to dissect this more. So that is basically all we need to know about interlocking of dimensions. So this is going to be the part 2 to the part 1 I uploaded earlier. Then I think I will still do more. There will be part 3. Stay tuned. So don't hesitate to subscribe to my channel. Thank you. God bless you.